Fourier transforms are an incredibly important part of mathematics and are used in many different fields. One common use of them is in eliminating unwanted noise. That's pretty useful, but what is a Fourier transform? Fourier transforms are a type of function that takes a complicated waveform, or a wave made up of many different frequencies, and separates it into the separate frequencies that make it up. Instead of actually separating those frequencies into many different waves, it instead shows us the strength of each frequency that makes up the wave. For example, this sound file, which is of the notes A and C, which are 440 Hz and 261 Hz respectively, will have a Fourier transform showing peaks at x equals 440 and x equals 261. So how does it know what frequencies make up the actual wave? Well, let's take a look at this relatively simple wave here. If we place markers at a frequency of 2 and look at the height of the graph at each of those markers, we can see that the markers correspond to peaks in the graph, meaning that one of the frequencies that makes up the graph is 2. Instead of simply checking the height of the markers, we can wrap up the graph around a point so that all the markers line up along the x-axis. When these markers line up with the peaks in the graph, the center of mass of this wrapped up graph is further to the right. This means that if we take the average x value of the new graph, we get the corresponding amount of the frequency we are checking. As we continue to check frequencies, plotting the strength of each one, we create a new graph that shows us the strength of each frequency in the wave, with the x value being the frequency and the y value being its strength. If we do the same thing with our new graph but wrap it around the other way, we will get our original wave. Using this, we can remove unwanted frequencies in the Fourier transform, and when we change it back, we will get a new wave without the unwanted frequencies. If we go back to our Fourier transform of A and C, we can remove the A note in the Fourier transform and we can change it back, and we will be left with just the C note.